Hi, my name is Miss Jessica, and today I will be reading Magnets, Pulling Together and Pushing Apart, written by Natalie Rosinsky. Let's begin. We have our table of contents here that shows us some of what we will be reading about, since this is a non-fiction book. Amazing magnets. Magnets have the amazing power to make things move. When strings pull and lift things, it's easy to see how they work. Magnets seem to make things move by magic. Watch a paperclip scoot to a magnet. The paperclip slides along as if pulled by an invisible string. Magnets pull only on special kinds of metal. Try to move a steel spoon or an iron nail with a magnet. Now try a ball of cotton, a rubber ball, or a plastic pen. How do magnets work? Magnets can only pull on things that are close enough to them. Put a paper clip far away from a magnet. Slowly move the paper clip closer and closer. How close does it get before it leaps towards the magnet? Magnets can work through a covering if it is thin enough. Lay a sheet of paper over your magnet and place the paper clip on top of the paper. Or try putting a piece of plastic wrap or the corner of your shirt on top of the magnet. What happens to the paper clip now? Dangle an iron nail from the end of a magnet. Now touch a paper clip to the nail. The paper clip sticks to the nail. The nail has become a magnet. When some metal objects touch or get close enough to magnets, the metal objects become magnets themselves. Pull the nail away from the magnet. Does the paper clip still cling to the nail? Rub a steel spoon along a magnet. You can feel the spoon being pulled towards the magnet's ends. These ends are called poles. A magnet's power is strongest at its two ends. One end is called the North Pole. The other end is called the South Pole. Fun fact, if you break a magnet apart, you have two new magnets. Each separate piece has its own North and South poles. The poles of a magnet can push as well as pull. Poles that are alike repel each other. The North Pole of one magnet will push away from the North Pole of another. Fun fact, in Japan, some high-speed trains use extra long magnets. Magnets on the train repel or push against magnets in the track. The train seems to glide on a cushion of air. Extra strong magnets, not mud. Opposite poles attract each other. One magnet's North Pole will stick to the South Pole of another magnet. Magnetic Earth. Earth is a giant magnet. It has two ends or poles just like other magnets. Earth's magnetic ends are close to the North and South poles that are shown on a globe or a map. The cold North Pole and South Pole covered with ice are not the same as the Earth's two magnetic poles. How does a compass work? Earth's magnetic power pulls other magnets. The needle on a compass is a tiny magnet. The needle always lines up in a north-south direction, pointing towards the magnetic poles of the Earth. Fun fact, a compass won't work if you're standing too close to the cold North Pole. The needle points to the Earth's magnetic pole. Once you travel past that magnetic pole, the needle does not point northward anymore. A compass shows us what direction we are moving in, north, south, east, or west. Sailors once used compasses to cross the ocean and find their way back home. Magnets all around. Some of the Earth's rocks have magnetic powers. Long ago, the Greek and Chinese people discovered the rock magnetite. Fun fact, another name for a piece of magnetite is a lodestone. Lodestones were used to make the world's first compasses. The Greeks were amazed as they watched magnetite pull small pieces of iron. The ancient Chinese hung splinters of magnetite from strings and watched rocks line up in a north-south direction. Today, electric fans whirl, refrigerators hum, and burglar alarms ring with the help of magnets in their motors. Huge magnets help junkyard workers lift tons of scrap metal. These magnets move cars and trucks as if they were small toys. Doctors also use magnets and special machines to look deep inside your body. Magnets push and pull us all around the world. And then at the end of this book, if you have your own copy, we have some experiment ideas if you want to experiment with magnets, as well as a glossary, index, and additional resources.